Lesson 5.2, Graphing Polynomial Functions. In this lesson, we're going to be using a graphing calculator to explore different types of functions. The first function we're going to be looking at is a linear function, and you can see on the graph, I've graphed this line, f of x equals x, and the domain is all real numbers from negative infinity to positive infinity. The range also goes from negative infinity to positive infinity, and as x gets positive, y also gets positive, and as x goes to the left, y goes down. The next function is a quadratic function, f of x equals x squared, and the domain is going to be from negative infinity to positive infinity. The range starts at 0, and it's going to include 0, and it's going up, so that's going to go up to positive infinity. And as this function goes left, it goes up. So as it goes to negative infinity, it'll go up to positive infinity. And as it goes right, it will also go up to positive infinity. The next function, f of x equals x cubed, is a cubic function. And this one, the domain goes from negative infinity to positive infinity, and the range also goes from negative infinity to positive infinity. And as the function goes to the right, it goes up forever, so it will go to positive infinity, and as the function goes left, it will go down to negative infinity. The next function, f of x equals x to the fourth, is a quartic function. The domain here is from negative infinity to positive infinity. And the range, again, looks like it starts at 0, and it's going to hit 0, and then it'll go up to positive infinity. And as x goes to the right, y also goes up, so it'll be positive infinity. And as x goes to the left, this function goes up to positive infinity. This is a fifth degree polynomial, or a quintic function, f of x equals x to the fifth. The domain will be negative infinity to positive infinity, and the range will be the same, negative infinity to positive infinity. And as this function goes to the right, it will go up to positive infinity. And as this function goes left, it will go down to negative infinity. This is a sixth degree function, f of x equals x to the sixth. This one doesn't have a name, it's just a sixth degree polynomial. But the domain here is negative infinity to positive infinity, and the range will start again at 0 and go up to positive infinity. As x goes to the right, this function will go up to positive infinity, and as this function goes left, it will also go up to positive infinity. Now we're going to look at some different types of functions, and we're going to look at factors, intercepts, and maximum minimums, and turning points. So this first function, f of x equals x to the third, how many distinct factors does it have? Well, x to the third, it has one distinct factor. Looking at intercepts, it looks like it crosses the x-axis at 0, and you can see from the table it does, so the x-intercept is 0. And is the graph tangent to the x-axis, or does it cross the x-axis at each intercept? And in this case, it crosses at x equals 0. How many turning points does the graph have? It doesn't turn. It just continues to increase the entire way through the function. So even though it bends, that's not a turning point. how many global maximum values, how many local maximum values that are not global. In this case, there are no maximum values because it just keeps increasing the whole way. And the same thing, there are no minimum values either. Next graph, x squared times the quantity x minus 2. How many distinct factors does it have? 1, 2. So 2 distinct factors. What are the graph's x-intercepts? Well, it looks like here it looks like it's 0, and it also looks like 2. So this had 2 distinct factors. What are the x-intercepts? 0 and 2. So we can get that. We can verify that from the table. So we're looking at where the y value is 0. Later we'll learn how to do this algebraically too. Is the graph tangent to the x-axis? So right here, where this graph comes up and touches the x-axis, that's tangent. So it's tangent at x equals 0, and then it crosses at 2. Crosses right here at 2. It goes right through and crosses. How many turning points does it have? It has 2 turning points, so it is increasing, and it turns right here to decreasing, and then it turns right here back to increasing. So this is a turning point, and that's a turning point. So it has, now it says, does it have any maximum value? So it doesn't have a global maximum, but it has a local. This is the right there. That point is a local maximum because it reaches a high point, and then it turns and decreases, and then it goes back up. And then how many local minimums? That would be this one right here. Next equation, x times x minus 2 times x plus 2. You can see there are 1, 2, 3 distinct factors. And the x-intercepts looks like it's 0, 2, and negative 2. So 0, negative 2, and 2. You can verify from right here. When y is 0, x is negative 2. When x is 0, y is 0. And when x is 2, y is 0. So those are my 3 zeros. You can see it from the graph, from the table. So it's going to be, all these go through, so it's not tangent anywhere, but it does cross at 0, 2, and negative 2. How many turning points? So it turns here, and it turns here. So it has 2 turning points. And then it says any maximum or minimum. So here's a maximum, that's a local maximum, and then here is a local minimum.